viruses can change much quicker than a lot of other species, and that can happen even within an individual. And viruses are obligate parasites, so they basically can only make more copies of themselves within our cells. So they want to adapt to their environment as quickly as possible to make more copies of themselves. It's this Darwinian selection of a race to make more viruses. And these viruses don't care if they make mistakes. So a lot of the time, they'll make so many copies of themselves, they give a new chance for the selection of a fitter virus, of a virus that's able to evade an immune response. And that's why we see these variants emerge, because they make so many copies of themselves. They're trying to win that race of evolution so that they can infect the next host. But if we're able to effectively contain that one strain of virus, it can't get on to the next person. So we're normally infected with a cloud of viruses. So when we're infected with flu, maybe we get infected with 200 to 2,000 particles of virus. So it's not just 200 of the exact same virus, it's a cloud of quasi-species that can then be selected upon in the next host. And that's how you have the variants propagate through a population.
Based on the virus that we already knew, which emerged in late 2019, we know that the virus was already quite stable within humans. And however, the virus may not be stable in another organism and it could collapse. However, we know that the virus was quite stable in humans and evolving. These variants was actually unexpected. Many evolutionary biologists did not expect variants to emerge so quickly, especially because for the first 6 or 7 months, we did not see the virus change as much, indicating that the virus was quite stable. But however, again, the host population, we are not quite the same. We are quite heterogeneous globally, and we do have a proportion of population who's immunocompromised, and their immune systems cannot get rid of the virus really quickly. So the current hypothesis is that these variants would have most likely emerged in people who are immunocompromised, where the virus was able to survive in these people for a longer period, and hence the virus needs to adapt to this host for that period, and hence these mutations emerged. And now the theory is that they can emerge consistently, and that's why we need to continue monitoring these viruses until we completely eradicate it.
This virus is considerably stable, but this is actually a relative terms, right? Because it is an RNA virus. RNA virus by nature actually is, they like to mutate. It happens all the time. So when you infect a cell with a virus, RNA virus, the infected cell will generate a lot of variants. So we call it mutations. This minor mutation sometimes is lethal, sometimes not. So this is actually very common to have such phenomenon. So for RNA virus, like corona, when it infects individuals, by default, it will generate variants. The problem is whether these variants actually create a public health concern or not. Like example I told you before, whether it will enhance transmissibility, whether it will enhance the pathogenicity, or whether the existing vaccines is going to be effective or not. So this is the question, key question in terms of public health. For me, what we need to know is whether this variant will spread to other community or not, right? If it is the case, then that will become a problem.